Assalamualaikum students, Alisar here, welcomes you again to our unit of limits, and today we are going to do the proof of some standard theorems beta that will help us to find out the limit of function is very easily. The first form that we are going to solve today is limit x tends to a, xn minus a n divided by x minus a is equal to n a n minus 1. What it means is beta, if we have a function that is of the form xn minus a n divided by x minus a. If we have a function that is of this form, and if in this function we will approach this x to a, we will tend this x to a, at that time beta, the value of function will approach to this n minus n into a n minus 1. And so beta here, the theorem says beta, if the values of this x are very near to this a but not equal to a, they are very close to this a, at that time the values of the function are getting close to n a n minus 1. But when our function is of this form, so we are going to give the proof of this theorem, but before that we are going to find out the application of this theorem. We will solve some basic examples beta that will help us to understand it very beautifully beta. Now, before going to solve the example beta, I must say you please have this mute on your meeting, because beta, when you will put your meeting on mute, you will get my voice clearly. So keep it on mute. Now beta, if I have a function f of x equals to beta x raised power n minus 3 raised power n divided by x minus 3. If I have a function that is of this form, and I have to find out limit x tends to 3 f of x. How we can find beta? We know that we can find it. The first method is the direct method, but when we are going to give the value of x directly as 3, we will get here 3 raised by n minus 3n, that is 0, and divided by 0, it will be indeterminate. And we know that to solve the indeterminate form, we have to factorize both numerator and denominator. But it is difficult here to factorize the denominator and numerator. We can factorize beta, but here it seems difficult. And when you are not able to factorize the denominator and numerator, after that we have this theorem, and the theorem says beta, you have to make the function same as to this function, and then you can compare these two and get the result. Now beta, here limit x tends to 3 f of x is equal to beta limit x tends to 3 x raised by n minus 3 raised by n x minus 3. This limit is same as to this limit. Now by the theorem says beta, the limit is equal to beta n a raised by n minus 1. But what is n here? N is beta same as n. A is here 3 beta. You check, n is 3. So it will be 3 raised by n minus 1. So this is our answer. Now we are going to solve another example. If we have a function beta f of x equals to x raised by 5 minus 30 divided by x raised by 3 minus 8, and if I have to find the limit at x tends to 2 f of x. So how can we find it? Beta, we know that first method is direct method, but that is not possible here. After that we have factorization method. We can factorize these two. That is possible, but it seems difficult now. And after that beta, we will go for this theorem, and we will try to make this function same as to this function. Here we have limit x tends to 2 f of x. It will be equal to beta limit x tends to 3 f of x, that is x raised power 5 minus 30 divided by x cube minus 8. which is for the equal to beta limit x tends to, this is 2 beta here, sorry, to x raised power 5. We know that beta, this 30 is equal to beta 2 raised power 5, because 2 into 2 into 2 into 2 into 2 is equal to beta 2 raised to 5, 2 power 5, and that is equal to beta 2 to the 4, and 4 to 8, and 8 to 16 to 32 beta, sorry, 32 we will take here in fraction. So it will be here beta x raised power 5 minus 2 raised power 5 divided by, here it is x cube minus 8, we know that that is equal to 2 into 2 into 2, that is 2 power 3. And this beta we got a limit x tends to 2, x power f of x, we got it equal to limit x tends to 2, x power 5 minus 2 power 5 divided by x cube minus 2 cube. Now beta, if we will divide both numerator and this denominator by x minus 2, we will not get any problem beta, because that x minus 2 will go cancel out and we will get our function back. So here we can write beta limit x tends to 2, x raised power 5 minus 2 raised power 5 divided by x minus 2, and divided by this x cube minus 2 cube divided by x minus 2. This x minus 2 we can cancel out and we will get our function back. We know that beta another result, that is this limit x tends to a f of x divided by g of x is equal to beta limit x tends to a f of x divided by limit x tends to a g of x. That means beta we can give this limit to both numerator and denominator. We have this theorem beta, we have already proved it. Now here we can apply this. This will be equal to beta limit x tends to x raised to power 5 minus 2 raised to power 5 divided by x minus 2, and then limit x tends to 2 x raised to power 3 minus 2 raised to power 3 divided by x minus 2. Now when we will compare this f of x to this and this g of x to this, we are getting these two functions same as to this function, but here we have something different. A we have 2 and n we have 5, and in this function we have a2 and n 5, and we know that beta it is n is 5, this one beta this in limit into a is 2 power 5 minus 1 power n minus 1, that is 5 minus 1, divided by here it will be beta n, that is 3, into a, that is 2 power n minus 1, that is 3 minus 1. It will be further equal to beta 5, 2 power 5 minus 1, that is 2 power 4, and we can write that beta 2 power 2 into 2 power 2, that is 4, and here in denominator we have 3 into 2 power, what beta? 2 power 3 minus 1, that is 2. And this 2 power 2 and 2 power 2 will get cancelled. We will get beta 5 into 2 power 4, that is 2 power 2, that is 4, and 5 into 4, that is 20 divided by 3. This is our answer. So now I hope, I'm sure you have got it. Now beta, we are going to give the proof of theorem. Well, now about to solve the theorem, and I hope beta, I am telling you again, कि आपने ये थ्योरम जो है ये अंडरस्टैंड की होगी विद हेल्प ऑफ दिस एग्जांपल. नाउ बेटा before going to the proof beta, I have already given you beta the expansion of this x raised power n minus a raised power n divided by x minus a is equal to beta x power n plus a x power n minus 1 plus a x power n minus 2 plus a2 x power n minus 3 plus so on plus a n minus 1. I have already given you this expansion in our previous lecture. How we are getting this expansion, I have already told you that also that beta we are getting this expansion with the help of long division. We are dividing this x n minus a per n by this x minus a and we are getting this expansion. So here we will apply this expansion and we will get the result. Write down the proof beta. Proof. We know that x power n minus a power n x minus a is equal to x power n minus 1 plus a x power n minus 2 plus a square x power n minus 3 plus so on plus x power a power n minus 1. Now this limit x tends to a x power n minus a power n divided by x minus a is equal to limit x tends to a this beta and we have this this one equals to this. We can replace this by these things, this expansion. So here it will be xn minus 1 plus ax n minus 2 plus so on plus a n minus 1. We know that beta we can put this value, put the value of x as a when we are getting the value of function as finite. But here when we will give the value of x as a, we are getting here finite value. So we can so limit of here x tends to a beta, it is f of x is equal to is here f of a because we are getting it as finite. So I can give the value of x as a here directly. So I will get x it is a n minus 1 plus here it is a into x n minus 2, that is a raised power n minus 2 plus so on plus a n minus 1. Now beta this is equal to a n minus 1 plus base of same powers are added. So this is a power 1 and a power n minus 2. When I will add the powers, it will become a 1 plus n minus 2, that is n minus 1 plus a n minus 1 plus so on plus lastly I will get a n minus 1. So I am getting a n minus 1 added by how many times beta? Here n times. So beta it is equal to beta now a n a raised by n minus 1 because this a n minus 1 is added how many times? It is added by n times with itself. So it so hence proved beta यही करना था proof हमें कि limit of this function is equal to n a n minus 1, hence proved beta, and you know now how to apply this theorem. The next theorem is better prove that yes, limit x tends to 0, a raised power x minus 1 divided by x is equal to 1. Now we have another theorem beta that says beta this limit of this very function is equal to 1. So we will give it this proof, but before that we will try to find out the application of this theorem beta. If we have a function equals to beta a raised by 2x minus 1 divided by 2, and I have to find the value of this function when we are approaching this x to 0. So this limit x tends to 0, we have to find f of x beta. We know that beta this limit x tends to 0, it will be equal to a raised by 2x minus 1 divided by 2 divided by 2. But here we have beta e raised by x minus 1 divided by x. The power we have to this e, that is also divided here in denominator. So here we have to make this same as to this, and after that we can apply this theorem beta. Now it is limit x tends to 0. We have e raised by 2x minus 1. We have here 2, I can write 2x, and then beta x is now, I will multiply here because x and x will get cancelled and we will get our result back. So it will be beta limit x tends to 0, a raised by 2x minus 1 divided by 2x. We know that beta when x tends to 0 and x tends to 0, 2x also tends to 0, 3x also tends to 0. So similarly beta here is x tends to 0, that means beta we can say here also 2x tends to 0. So here it will be limit 2x tends to 0, e raised by 2x minus 1 divided by 2x, that is beta 1, into limit x tends to 0 x. We know that we can use the value of x as 0 in this when we are getting the finite, but when we will give the value of this x as 0, we will get 1 into 0, that is finite beta. So we can solve this by direct method now. 1 into 0, that is 0 beta. This is our first example based on this. Now beta another example we are going to solve that will be based on this. If we have now beta limit x tends to 0, a raised power 5x minus 1 divided by x. If we have function like this, how we can find this limit beta? So this will, I can write this as limit x tends to 0, e raised power 5x minus 1 divided by 5x, but 5 is here extra now. I will multiply this 5 and this 5 will get cancelled out to this, and I will get my function back. So it will be now limit x tends to 0. We know that when beta this when x tends to 0, kx also tends to 0. So here we have 5x, so that means when x tends to 0, this 5x will also tend to 0, and after that it will become limit 5x tends to 0, e raised by 5x minus a minus 1 divided by 5x. That is by this theorem beta 1, and this 5 is constant, will 5, and 1 into 5, that is 5. 5 is the answer of this limit, and we have found this with the help of this theorem. Now we are going to do the proof of theorem. We know that beta this already I have given you the expansion of this e raised by x beta. You can find out the expansion of this e raised by x just as we have found for xn minus a raised by n divided by x minus a. We have found this expansion, the expansion of this by the help of long division. But here we can find the expansion of e raised power x with the help of beta. Taylor's theorem or Taylor's theorem, we can find out this expansion. And beta that is equal to, I have already given you beta 1 plus x square divided by 2 factorial plus x cube divided by 3 factorial plus 1. So beta, we are going to write the proof of this. We know that, to write it, we know that e raised power x is equal to 1 plus x square divided by 2 factorial plus so on. So now limit x tends to 0, e raised power x minus 1 divided by x is equal to beta. We can write it as limit x tends to 0. E power x, we can replace it by this expansion, so it will be 1 plus x square divided by 2 factorial plus so on. Then we have lastly minus 1, and in the denominator we have x. This is minus, this is plus 1, this is minus 1, these two will get cancelled, and we will get limit x tends to 0, and it is x plus x square divided by 2 factorial plus so on divided by x. We know that beta, when we have the form 0 divided by 0, because when we will we have quotient method, direct method, when we will give the value of x 0, we will get in the numerator 0 and in the denominator 0 also. But when we are getting the form the 0 divided by 0, after that we have another method, that is factorization method. So we will factorize this both numerator and denominator. When we will factorize the numerator, we have x here in this term, also in this, and we have x in fact in all the terms. So we will make common this x, and here it will be 1 plus x the 2 factorial plus x square divided by 3 factorial plus so on. All the terms that are inside now, after this 1, they have x with itself. So here it will be now x. We know that after that we have to cancel out the common factor. So here it is x and it is x, they will get cancelled out. And the method says after that you can give the value of x as a, that is x, we can now give the value as 0. So it will be here now 1 plus 0 divided by 2 factorial plus so on. All the terms that are after this 0, after this 1 are 0. So it will be 1 plus 0 plus 0, so it will be 1. Hence proved the cannot have proved it is the limit of this function is. So we have done this. So on our second theorem, our third one is beta. We are going to now do the proof only, and application we are going to find out tomorrow beta, because time is not waiting us. Okay beta, theorem 3, that is limit x tends to 0, 1 plus x 1 divided by x. This is our theorem beta, but we have to show that beta, to prove that we have to prove this as this is equal to beta e is equal to e, and we know that the expansion of e raised power x is equal to what? 1 plus x square divided by 2 factorial so on. So e power 1, that will be beta 1 plus 1 plus 1 divided by 2 factorial plus 1 divided by 3 factorial plus so on. This is our expansion of e. So we have to find the limit of this function is equal to either this e raised to power 1 or this expansion. So we know another result will be that 1 plus a raised to power n. I have given you the expansion of this, that is beta equal to what? 1 plus n a raised to power n minus 1 plus n into n minus 1 a raised to power n minus 2 plus n into n minus 1 2 factorial n into n minus 2 divided by 3 factorial a raised to power n minus 3. So this is our expansion of this 1 plus a raised to power n. We will apply this here. So you write on the proof beta. We know that one plus a raised to power n is equal to 1 plus a plus n into n minus 1 a raised to power n minus a raised to power a divided by 2 factorial, and then we have n into n minus 1 n minus 2 3 factorial a raised to power 3, and lastly we have beta a power n. So we will apply this beta here. It will be now beta this 1 plus x limit x tends to the 0 1 plus x 1 divided by x. We have here n as 1 divided by x and a we have x, so it will be 1 limit x tends to 0, then it will be 1, that is 1 plus, after that it is n is 1 divided by x, and then a, that is x, plus we have after that n into n minus 1, that is n is 1 divided by x into 1 divided by x minus 1. After that we have a square, that is x square divided by 2 factorial plus so on, plus lastly we have a raised to power n, that is x raised to power 1 divided by x. It will be further equal to beta limit x tends to 0. Here it is x and x will get cancelled, 1 plus 1 plus 1 divided by x 1 divided by x minus 1 x square, so plus so on x 1 divided by x. It will further equal to limit x tends to 0. This is a bit of 2 factorial, so on. So limit x tends to 0 1 plus 1 plus, here it is 1 divided by 2 factorial 1 divided by x. When you will multiply this to this, it will be 1 minus 1 divided by x 1 divided by 1. It will be here 1 minus x 1 minus x, then divided by x square into x square plus so on plus x raised to power 1 divided by x. So it will be further equal to beta limit x tends to 0 1 plus 1 plus 1 divided by 2 factorial. Here you will check beta, it is this x square and x square will get cancelled. It will be 1 minus x plus so on, beta plus, and this is Now out here, this will further equal to beta. When we will give the value, because it is now getting finite, when we will give the value of x as 0, it will be 1 plus 1 plus 1 divided by 2 factorial 1 minus 0, that is 1 divided 2, and then plus 1 minus 1 divided by 3 factorial plus so on, and this is equal to beta e raised power 1 is equal to hence proved beta. This was beta. I will give home assignment. You have to solve that, and that will be our final theorem now. This beta home assignment theorem ही है, लेकिन वो आपको घर में करनी है. That is beta limit x tends to 0 a raised power x minus 1 divided by x is equal to log a. Another beta you have this limit x tends to 0 1 plus x raised by n minus 1 divided by x is equal to, and these two you have to prove beta. How you can prove them beta? Here you can apply the expansion of this a raised by x which I have already given you, and in this function you can use the expansion of 1 plus x raised by n, that is our previous expansion, and you can get the result. These two are very same to our previous results, and you will easily solve them. And this is our final. Now tomorrow we are going to solve some examples, and also we are going to find out some more theorems that are based on trigonometric functions beta. So after here, all the theorems were based on algebraic functions as well as this exponential and logarithmic function. Now we are going to solve the theorem that will be based on trigonometric functions.